Okay. One more time. Hello, dear students. Today, first of all, we continue materials from previous lecture about statistical methods in with relationship to medicine and usage of spreadsheet to implementing those methods. So right now we will consider a topic related to identification potential relationship between variables. By example, how it can be identified by using correlational analysis. Then we will check regressional models as approach to make the prediction of development of some uh, features, behaviors, and so on of some processes. And then we will move into introduction of optimal management task, which is not exactly statistics, but also a bit interesting. Okay, spoken about correlation. First of all, definition, and then place of it among other kind of statistical analysis. So under correlation, we understand statistical techniques that show whether and how strongly pair of variables are related one to other. So here is main points. Pair of variables, so applicable only if we have two variables. The measure of correlation is correlation coefficient ratio -1 to +1, and so close to those values, we are talking about that variables more relationship between variables are more powerful. And when we square coefficient of correlation, we will get coefficient determination, which show percentage of variation in y, which is explained by all of the x variables together. So this one we will also use. In fact, when we will turn to like general approach about identification of relationship between variables, so we can use also the following chart, which is actually extension and like even maybe more comprehensive representation of that table I shown for you on previous lecture about which was useful to make the choice about statistical hypothesis testing. In this case, we have combined multiply type of analysis on one diagram, depending to what do we want to do. So like univariate, multivariate analysis, depending what we are looking for. Difference or some similarity between variables, depending what kind of data paired and paired test do we have, what kind of outcome we are expected, what kind of our data do we have, distribution type, normality. So here is those type of variables like continuous, nominal, and so on. Then again, depending to number of variables, groups, variables, and here is at right side listed all available tests, which is not so as you can see here is listed some tests you already aware about when I was talking about hypothesis testing, those sets above, and here is we have place of correlation, and as you can see we have at least three type of correlation depending of what kind of data do we have and is it our data normally distributed or not. So for continuous data we have Pearson-Spearman correlation depending if it's normally distributed or not, and for nominal data we have we could also use version of Spearman correlation, especially adopted version of Spearman correlation as well. So here is general place. Again, at this point, I want to make emphasis that's correlation. It's not something separate. It's one of the method of statistical analysis in the same lane as hypothesis testing or further regressional analysis, which will be our next topic. They are all listed there together. Uh, Again, so I already admitted that we have two main approach to retrieve correlation coefficient, depending what data type do we have, continuous or nominal, and depending is it normally distributed or not. In case of continuous normally distributed data, we use Pearson. Other hand, we use Spearman rank correlation. So here is shown how it's possible to be obtained by using statistical formulas. So we can do it definitely by hand, and it's what had been done for decades, even not 100 years this way. But of course, with spreadsheet, it's much easier to be done. And at the right side, we have one of the approach to identify, to interpret, to make conclusion, to make interpretation about what you are getting off. So what means that particular value of coefficient correlation, depending to how close it to one, we have few values, a few possible level of interpretation, like high correlation, which is no matter is it at 1 or +1 or -1, it's highly correlated. Or if we talk about, because sometimes students made mistakes talking it, if it's -1, it's not correlated. No, it's very high correlation, just it's mirroring of data. And if we talk, there is no correlation, it's closely to 0. So here is we have, here is given source. So actually, if you have suspect relationship between data and you want to prove that they are present or not, so correlation is applicable by data type. So it can be done this way. And here is we have, for example, Corel function in spreadsheet, which can give for you example of ideal positive negative correlation, which is in fact almost never happen. We will have close but not so close values and so on. And actually, if you have more data and you want to retrieve all possible paired correlation, so correlational tool under data analysis will help you, and it will produce matrix of correlation like this one. And here, as you can see in your case, it's easy to determine that we have 3 coefficient of correlation, and we have very strong positive correlation between A and C, because 0.9, and very weak, almost negligible correlation between C and B, between B and I, because they are very close to 0. Okay, stop cover fitting. It's a little bit too early. Okay, I think it's possible to show this practically like I did it. So here is I have similar examples, 3 variables. If I want to do it by hand, no problem, I can do it by Corel function and provide arguments for like this pair of variables, and I have like very significant correlation, 0.78. And if I want to do it with data analysis, so for me given correlation 2, this time I can include headers. Just not forget to make select that I have labels in first row, my data in columns, and I want to present my results starting from given cell. And here is I have okay, so here is I have strong positive correlation, like this one. I have also very good negative correlation. Here is we have a little bit softer a little bit softer, and we have moderate negative correlation there. Moderate negative correlation between Z and Y. So here is we have. And of course, as you can see, between X and Y, my data matched. Okay, so that's, as you can see, this method of analysis really very easy. It's only need to properly determine which method you want to use. Important notice: if in this demonstration I have not tested is it my data normally distributed. Definitely it was continuous, but I have not tested distribution. So if, of course, it's possible to use that recommendation from previous lecture, like skewness kurtosis for simplicity, or 3 sigma method. And if you will see that your data distribution of your data deviate from normality, you must use Spearman correlation. And important to know that in spreadsheet, both analysis toolpack and formula calculate only Pearson correlation. So if you need Spearman, you must use correspondent formula and do it by hand in spreadsheet. That's important points. Okay, now move into another approach. Let's say third question, like with hypothesis testing, you can answer about potential presence of effect of one variable's input variables over output. With correlational analysis, you can make answer about potential relationship between two variables and how strong this relationship is. And we have third question when we have developing of some processes, usually through time. And for us, it's interesting, not current development, but future changes. Future changes, for example, that's important in case if you want to now expected cases of new infections, how infection will spread during epidemic or global pandemic like COVID, and so on. Or, for example, kind of sales volume or expected number of visits, patient visits into your office, and so on. So in this case, it's covered, we have to apply regressional analysis, which is in fact not something single, but set of method for estimation relationship between dependent variable and one of more independent variable. Actually, main outcome of regressional analysis, it's mathematical model which depict relationship of variables. And so this model could be used to establish, to make prediction, to evaluate future values. Actually, it's not only using with time, it's just time. It's most common case of independent variable for regressional analysis, but works not only for time. So, and speaking of methods, for example, one of the simplest and most common, it's curve fitting, which we want to try to find curve, some typical, adopt typical type of curve that will be best represent our data sample. And from that curve, because again, we use not free but only standard curves, standard models, we will retrieve some mathematical model we are interested in. So let's remember most common type of trend lines of those curves. Of course, it's a conventional linear equation, kx plus b. So we need determine if we have suspicions that our data have developed according to linear types. So we need to determine this value. In other, it's logarithmic. Again, everything things has to be known from school, not even lyceum, but school. With logarithmic, we have again pair of coefficient to determine, has to be determined, power, exponential, and finally, again, those very known equation, and polynomial. Here is specifically shown polynomial of the sixth-order polynomial. Why I limited this? Because it's highest supported by spreadsheet version. So actually, usually with color fitting, we assume that one of these models very likely to our sample data, and we try to figure out characteristics of those equations. And actually, Excel can do it very easy for us with things called color fitting or trend line, with Excel trend line. So here is spoken about how to add trend line on chart. So first of all, you have to visualize your data with proper type of chart, and then you can easily add the trend line to your data series, and Excel will automatically give for you appropriate mathematical model, and it will be look like something like here. We have with bold line, we have our sample data. With dotted line, we have our, in this case, third order polynomial. Here is spoken about sales, but we can replace sales with like number of clinical cases or so. So actually no matter. We have the used third order polynomial, and here is Excel automatically, as you can see there in the second step. So first step we choose line, second step we choose even graphical prediction. So we immediately, here is between 8 and 10, x 8 and 10, we see our predicted value expected by system, and at step 3 we can display our equation, display goodness of fit. So R squared value, coefficient of determination. So here is again this value has been used, which is obtained from correlation between our, in this case, between our sample data and our data calculated according to given model. So Excel first time calculate correlation, square it, and we got coefficient of determination. Okay, and here is we have more model. Here is, as you can see, we have our data with markers represented, and we have four different trend line. Like we have linear model here, we have power, we have logarithmic, we have exponential. So with previous slide, we covered all supported by Excel type of grid lines. And as you can see from this particular chart, so it's look like our data almost fit a linear model with coefficient of determination closest to 1. And the power is at second place of goodness of fit. In fact, when you will create a trend line that's technically it's very easy to be done, but practically we have the only one issue. We have to try to avoid overfitting. So sometimes we try to looking for as better model as it could be, and we got model with very high R squared value. Especially it's very easy to get such model with high order polynomial. If you increase it to 4, 5, or 6, you will retrieve much better value, but it will be very high risk of overfitting because prediction value will have very unexpected behavior, will demonstrate very unexpected behavior. Again, brief example how it's look like. So first of all, technically, as I already said, the first question is properly visualize our data. When we have, in this case again, it's labeled as sales volume, but we can change it to like hours timeline and number of patient visit per hour or number of infected patient per day in case of epidemic. So classes, maybe I will demonstrate COVID data set. Very one of the interesting outcome. We have very nice data set from COVID time. Okay, so of course, first intention would be to insert something like line chart. Unfortunately, this visualization is this approach definitely incorrect because we have only one data series. In fact, we have only sales on it's our data, and month number, it's our independent variable, so it's only number, it's like a label for x-axis. It's must not be depicted as separate line. So at least we have or remove it or use better type of chart, which will be in this case, of course, it will be scatter plot. Where do we have it? Will be scatter plot. We can use only with marker, we can use with a smooth line or with a straight line, actually not critical. So in this case, it's uh, scientific viewpoint, it's more better to use scatter plot. Despite originally scatter plot could be used to depict relationship between variables, actually to visualize correlation. But in case of of one independent, one dependent variable, it's also very useful of having of using it to visualize regressional data and especially time series data, which do it in proper way, because if we're talking about independent variable being continuous time or so, scatter plot expected two continuous variables, where linear chart expected independent variables as nominal name only. And I will show issue with this in minutes. Right now, but at this point, for this data, both almost equivalent. And you can add the thread line to both, and right now you will receive the same result. Let me add the, for example, linear. Okay, I made graphical prediction and display square values. So here is same way I can do it uh, for scatter plot. Also, display creation. It's important of having a creation and display creation. Okay. As you can see, in this case, we have the same equation, but let me show predefined example where those here is we have. As we're talking about dates, it might be that we will make observation at particular date. So here is example with dates and again sales volume per particular date on up to particular date, for example. And take a look, we do it with exact months. We have months between observation, except one case, when we have 1.5 months. And take a look about difference in this case between linear chart and between scatter plot. As you can see, there is no difference in interval between on linear chart, because again, it's expected that independent variable x, it's just nominal. So it's just use this dates as labels, not as exact dates. And as a result, we have literally not different equation and different squared value. In contrast, scatter plot treated dates as integer value, use integer value in place of dates, and here is made a correct alignment of that 15 of August. Here is, of course, we have missed months. determines that one value is missing, but it's not properly aligned exact 15 of September of August, among other. Scatterplot do it correctly, and this model is correct. Similar case if you do it just with numerical representation like this one, like my previous case. Again, as you can see, 7 is missed. It's even worse. It's even worse we have there with sales volume, as you can see, after 6 follow 8 without necessary gap. And in case of, again, scatter plot, we clearly see gap in our data, and we have, of course, correct model here. It's why scatter plot is correct to depict this data, and why scatter plot is correct to add thread line in such kind of tasks. So a similar way I can add the more thread line in the same chart. For example, here is what I will add the, let me show, I will add the third order polynomial. Again, I will make prediction to period forward, this prior creation. And let me add the one more time, second order of polynomial, this prior creation. So as you can see, you can compare these two cases. We have here, we have one, it's my linear. So here is, we have one type of polynomial. It's demonstrate development closer to linear. And we have third polynomial, third order, which demonstrate quick decline. So this case, it's exactly what I'm talking about, overfitting. That's exactly that one. With high probability, this model, despite its having better R-squared value, it's almost certainly that it's overfitting and this model is wrong. And probably second polynomial, second level would be better to make our assessment, despite its squared value quite smaller. But it's closer. Yet in other approaches, or more approaches for provide regression analysis, you can consider smaller segment, which is almost linear or so. But here is, we have this case. We have quite probability of overfitting with third order model. Still, if we're talking about practical classes, I will accept even such answer. I will not talk that it's wrong, but we have to keep in mind that we, with regression, we're very often at risk of overfitting. Okay, I think we have to move forward. Where is our, okay, next. Introduction into optimal management task solving, and particularly transportation, tranship, and assignment models. So this task actually does not relate it exactly to statistical analysis. We are moving actually into linear programming, optimal solving methods, but still quite interesting and important. So generally, this problem spoken about distribution of goods from several points of supply to number of points of demand, and looking of cost-effective pattern of delivery, everything. So very common model task. But it's not only about this. Actually, under this mathematical model, far many different tasks and problems. For example, creating various schedules. So schedule of shifts of persons, of employees at work, or creating even schedule for educational organization. It's also a kind of transportation problem model, because it could be based not on cost effectiveness, but time effectiveness. And after that, it's turned to be same mathematical model. Unfortunately, only maybe, despite I know at least one software solution exactly specifically created to implement transportation problem for creating educational schedule, university timeline. Uh, but very few organizations I hear have tried to use it. It's every time it's very complicated problem, complicated matter to create schedule, especially in educational organization. Anyway, we have this so it's actually a segment. It's actually a segment task, which is uh, which is a subset of general transportation problem. So every time we come to optimization mathematical problem, objective is to minimize total cost or total time of performing task at hand, and always maximization of objective is also possible. Usually we try to minimize, but sometimes we need to maximize. Okay. Speaking of application, as I already said, it's many. I just show this what I'm talking about. It's like various transportation problems, logistic problems, but it's very widely used. It's used for delivering even some messages to communication channels. So this again, all this model works in background, even behind the user understanding, but they are present. They are present. And for example, delivery companies solve it every day, those tasks, usually without serious problem, just by using experience and specific software dedicated to that company. Anyway, you will try to like make some very brief simulation with spreadsheet of the classical problem where we have m source, and each I source has a specific capacity S of I, and we have n destination, so its destination J, and J, it's their demand D of J. So objective is minimize total shipping cost of supplying destination with required demand from available suppliers and the source. So here as we can depict kind of, it's about for delivery of pharmacy, from some factories to some destinations. Here is how it's required, capacity requirements, shipping routes. We are given cost per unit for each available route. And so we are going to retrieve schedule of delivery or delivery strategy with minimal transportation cost. So, what case if we have like not uniform units? Actually, it's being solved extremely easy, and our again delivery company do it by routine. So it's weighting and measuring. They or weight your packages. Uh, and also made assessment regarding some standard type of units. If your parcel fit with weight and size of standard unit, it will be counted as one standard unit. And so then basic model easy become applicable without any problem. Okay, as a result, speaking of mathematical model, it's called linear programming. Linear programming methods. Again, those things does not have nothing in common with computer programming. When we talk about linear programming model, we are speaking about development of methods to solving system of linear equation. Why it and in minutes I will show this. So major model solved for case when we have our transportation problem balanced. So if our amount of supply units are strictly equal to amount of demanded units. In reality, so in this case, we have few mathematical models which work perfectly in this case. In reality, it's always does not equal, but again, usual techniques, it's made assumptions and they are equal and added some imaginary components to our task. So how it could look like? We have like minimize shipping cost. We have equation, linear equation which with some coefficient, and our task is to find this roots of this for this equation. So here is we have how we determine its number of units shipped from particular factory to specific warehouses. And how it's label it, and then we are creating our constraints. We are creating our system of linear equation. So here is like our capacity and our capacity and different location, and demands for different location. And when, so as results, we have to have 6x and 6 equation, and it could be solved. So without any problem, it could be solved. And if we talk about spreadsheet, it's contains special tool called, by surprise, solver, which especially dedicated to solving tasks like this one. So only in fact you need, it will be prepare specific layout when you have to depict flow out or availability of resources, demand, so how many items required by our customers, and create cost per units, create objective function, which will be definitely multiplication of two matrix, cost matrix per transportation plan matrix, which is initially 0. And when you add the constraints, like how maximum we can take from and how maximum we have to deliver, solver will be capable for you to produce a necessary result. So here is shown how to configure a solver. We are given objective function cell. We are given objective operation like minimization. Here is target cell. By changing cell, it's our transportation plan. And constraints here is given equivalence between these points, and solver produce result. What's going on if we have unbalanced problem, if we does not have equality between resources and request? So we made adjustments. We made imaginary adjustments. For example, if supply greater than demand, we add dummy destination point. So easy way, if we have more resources, we just imagine that, okay, we have extra customer which utilize our extra things, of course, with zero cost because nothing being delivered. More complex situation if it does not have enough resource, but even in this case, again, mathematically, we simply add those resources which is not available. Imagine we are having it, and again create a source point with zero cost because not existent things can be delivered. Anyway, we do it this way. And again, we apply the same principles, yet a little bit in other layout, but again, similar. We have real resource. Here is we have unbalanced problem. We have unbalanced problem because our resources are smaller than our demand. You can see here is in brackets real results. So we added the dummy source point with dummy with dummy capacity and zero transportation cost, and made some configuration, the same configuration. Again, we are expecting integer solution and apply simplex linear programming method in spreadsheet solver, and we got this. In fact, again, we have a few minutes and I can easily show this. That's the same example. I already have the same data. I already have name dummy object added, so those things which is not available. As you can see, objective function definitely returns 0 initially because our transportation plan is empty at the moment. All constraints, which is like spoken, that's all has to be taken out from warehouse A, same up to D, and another set of constraints, it's maximum of items delivered into fast customer, and same for all this return 0 because 0 transportation plan, but right when we start our solver, I already have configured it. Again, as you can see, we have different approach to create constraints. It will be only referred to amount of items under constraints dialog. Of course, I want to minimize our transportation costs. So by default, it's not set to max and I want to minimize. And I start with solving and yeah, here is my transportation plan. Here is given number of items has to be delivered. The only issue is this one because here we have dummy object, so this 20 can't be delivered, so one of customers does not receive something, so we have to think about how to satisfy it or left as is. So again, very easy things to simulate. Okay, I think it's all what I had to talk about to complete about statistical methods and how spreadsheet could help you with solving it. So right now we will move into second part of lecture, but before this, I will change recording. So first of all,